Hello.
Hello.
Hi, ma'am. Good afternoon. Ma'am, just admitting the student now.
Rajan, this is going to be a 1 hour demo, no?
No, no, ma'am. Only 30 minutes.
30 minutes.
30 minutes. You can like check up to how many slides we can cover.
ठीक
Hello. Hello.
Hello.
Hi, Rudy. Can you please switch on your video?
Yes, sir.
Okay. Hi, Rudy. So we have Aishwarya ma'am with us. Okay. She will be your mentor for science today. Okay. So Aishwarya ma'am, you can just introduce yourself and then we can start with the session.
Okay. Hi, Rudhi. How are you?
Hello, ma'am.
Where are you from?
Mumbai.
Mumbai. Great. Okay. So, Rudhi, as Rajan sir has already told you, my name is Aishwarya and I will be your science mentor. And I have done my MPhil in botany and I belong to Delhi. Okay. And I've been teaching for competitive exam almost for 4.5 years now. Right. So, I hope when we do come for one-on-one, only thing I need is just interaction. It has to be a informal interaction so that you also learn and I also understand that you've understood or not, right?
Yes, ma'am.
Okay. That is the best way in which you can possibly make use of this one-on-one session, right? All right. Should,
Yes,
uh,
ma'am. You can start with the session.
okay. So Riddhi, what is happening in school? Have you started your school session?
Yes, ma'am. At school, we are doing nutrition in plants.
Nutrition in plants. Great. Okay, so today I'll be taking a demo for light, right? I think light is taught slightly in class 6th also, right?
Yes.
6th, 5th also. So I'm sure your basics are there. So that's why I'll just, let me just share my screen. Give me a minute. Okay. Can you see my screen?
Yes, ma'am.
All right. So what do you understand by light? Like the word light, what does it, what comes to your mind if you hear the term light? Anything.
Um,
Not
it allows us to see properly.
correct. It allows us to
It
see.
comes from the sun, and then we have the light bulbs and.
Correct. Correct. So basically, whatever we see around us, it is because of light, right? So if there's no light, we'll not be able to see. So let's say if it's a dark room, of course, you'll not be able to see anything. So how are we able to see because of the presence of light is, first of all, light is a form of energy, correct? That energy mainly is coming from the sun in natural, if you see, right? And normally at our homes or at our in our buildings and at night we use light bulbs, right? So mainly whenever light energy is getting emitted out, that light energy is getting reflected back. Because of that reflection, it makes the objects visible, right? So whatever is visible to you, that means light is falling on it. Only then will it be visible, right? So let's say if I now if I put my hand on my face, there's no light that is falling, so automatically you'll not be able to see my face. It's blocking all the light, correct? So first, to understand how light works, we have to understand the term reflection. Now, reflection is something which is a phenomena of light where all the light that is falling on a particular medium gets bounced back. Okay, nothing is getting absorbed. If something gets absorbed, then that will not be complete reflection. Then we call it refraction. That also we'll talk about in a little while. So reflection of light is the phenomena of bouncing back of light in the same medium. When we say in the same medium, that means, let's say light is traveling in air. Okay, so let's say you have a mirror at home, correct? When you stand in front, let's say the mirror is kept like this. When you're standing in front of the mirror, you see a reflection of yourself in the mirror.
Yes.
Right? Now, why is that happening? Because first, you are the one that is emitting light, right? You are the object. This mirror is the reflecting surface or the reflective surface. This mirror reflects back all the light that is falling on itself, which helps us to see the image. And this all happens in the same medium. That means you are present in your room, so the medium would be air. Your image is also in the air. Reflection, whatever reflection is coming back from the mirror, air. Why? Because if the medium changes, then the image can get distorted. So let's say if I see myself in water, sometimes if it's a stagnant water, there's lake, there's pond. If you look at yourself there, and if I slightly move the medium, obviously the image will also get distorted. Or even if it's completely still water, you will still not be able to see your image very clearly, right?
Yes.
So it has to be in the same medium, right? Now, just looking at this diagram that has been given in the slide, there are a few terminologies that you must know. Let me just move on to the next slide. I'll come back to this. Let's just first look at the terminologies. First of all, the ray of light that is falling on the mirror. Now, mirror can be placed any which way. In the first diagram, it was placed horizontally. Now it's vertical, right? Now, when you see this ray, whatever ray of light is coming from the object, that is known as the incident ray. Okay, here the incident ray is represented by AO. Okay, this is the mirror. Now, when the mirror is drawn, we call it a plane mirror because plane mirror is the most effective reflective surface that you can find. Okay, if it's not a plane mirror, then the object can be slightly distorted. Okay, so let's say sometimes, if the mirror is not made properly, or if the mirror has some kind of defect in it, you can see yourself slightly different. That means maybe in a mirror, you might look fatter than you actually are, or thinner than you actually are, shorter than you actually are. That is because maybe the mirror is not made properly. So a plane mirror is the most accurate reflective surface, right? Now, when this thing is drawn on the plane mirror, that means this part where there are no lines, the one without the lines is the reflective surface, and the one behind it is the coating or the polish. Okay, all right. Next, we have the reflected ray. Now, reflected ray is the ray that is getting bounced back when it hits the plane mirror. So this is being represented as OB or BO, whichever way. Now, always remember, incident ray and reflected ray will always be in the opposite direction, right? Obviously, incident ray is incoming and reflected rays outgoing. Now, just for an understanding, what we do is we draw an imaginary line that is perpendicular to the surface of the plane mirror. So if, let's say, the plane mirror is kept like this, an imaginary perpendicular line can be drawn like this also. This imaginary line is known as the normal. Okay. Now, this normal gives us an idea of how and where the incident ray and the reflected ray will be present, right? Now, there are a few rules when we talk about the incident ray and reflected ray that I will just talk to you about in a little while. Before that, the angle between A O and N. This is this. This angle is known as the angle of incidence. Okay, so the angle that is formed between the incident ray and the normal is known as angle of incidence. It is represented by small I. And the angle that is formed between reflected ray and normal is known as angle of reflection. That is represented by small r. Right? Till now, any doubt?
No, ma'am.
Okay, great. Now there are a few rules when reflection of light is happening on a plane mirror. First rule, the incident of light, incident ray, the normal and the reflective ray will all be on the same plane. That means will always be on the same side. Okay, it doesn't happen that incident ray is here and reflected ray is here. No, it will always be on the same plane. So if you look here, this is incident ray, normal and reflected ray all on the same plane or the same side. Okay. Second rule. Second rule is that angle of incidence will always be equal to angle of reflection. Okay. That is why whenever, whatever distance the image is at, whatever height the image is at, however the object looks like, the image will be an exact copy. Okay. So if this is, let's say 30 degrees Celsius, 30 degrees, this will also be 30 degrees. If this is 90 degrees, this will also be 90 degrees. If this is 45, 45, whatever will be the angle. So in Olympiad, sometimes a lot of numericals come on this. So they might just give you the incident ray or the reflected ray and maybe an angle here. Okay. And then ask you to find this out. Or they might just give you an angle for this and then ask you to find I and R. So it's simple mathematics. Obviously, this and this will make 90 degrees. You can minus. So let's say I'll give you an example. If this is given, this is the normal. And let's say this is 60 degree.
So that is 60 degrees and the INR are 30 degrees.
INR are
30 degrees.
correct. So this a few of these things will have to be found out. So this is the easiest one. Sometimes they give you a triangle as in, one mirror is placed here, another mirror is placed here. And what will be if the incident ray is falling, let's say here, and this is the normal for the first one, what might be the incident ray for the second one? So basically you'll have to form a triangle and find out. Right? I'm sure you must have learned isosceles triangle and all that in math, right? So you can calculate how to calculate the angle. Just remember I and R will always be equal and normal will always be perpendicular to the mirror. So when we come to regular classes, we'll do such questions. Don't worry. Okay. So this is the second rule. Third rule is that the incident ray and the reflective ray will always be on opposite sides of the normal. So in this case, we've drawn it here. Let's say if I draw the incident ray this side, then automatically reflected ray becomes this side. There's no hard and fast rule that incident ray has to be on the left side. This is just for our understanding. Okay, so these are the main three rules that you have to know for reflection by a plane mirror. Any doubt?
No, ma'am.
Okay, just going back, we had skipped one slide, so we'll just quickly read that slide. Okay, this one. So now sometimes what happens is if you look at the mirror, how is a mirror made? Do you know? How do you form a mirror? Like if I have a plain piece of glass and I want to convert it into a mirror, how do I do that? Any idea? No. So have you seen the back of the mirror ever? What is it? What color is it? Like a plain mirror without any cardboard or any kind of tape. No. So if you look at a plain mirror, behind the plain mirror, you will see a polish of silver. Okay. So simply when we polish it with a silver paint or a silver reflective surface, it starts acting as a mirror, basically because it becomes shiny, right? So it reflects back all the light that is falling on it. Okay, that is a plane mirror. Now, you will always notice that the image that is formed by a plane mirror is always erect. Correct? Obviously, you don't see yourself upside down. Yes. However, When you see yourself in water, you will see yourself upside down. Do you know why does that happen? That is also a reflective surface, correct? Water is also a reflective surface. But in this case, if you see, like here, the image is given, this is a tree. And normally, if it has a reflection on water or something, then it is usually upside down. It's not straight, it's not erect, correct? So why does that happen? I'll tell you in a little while. Okay. All right. So before I tell you what exactly is the difference between the reflection caused by a plane mirror and the reflection caused by other substances, sometimes you have certain reflective surfaces like, maybe your screen. Like if I switch off my laptop now, obviously I can see my reflection on the laptop, right? It's a black screen. Similarly, maybe your metal spoon or a metal plate, you can, in a steel plate, or maybe like a shiny tile, you can see your reflection, right? Now, every reflection is different, and every reflection will be depending upon what kind of incident ray is falling on it, right? So if the surface on which the incident ray is falling completely smoothly, that means the surface is a smooth surface, then the reflection that we see is all parallel to each other. That means whatever, see, now when I am the object, it's not possible that only one ray of light is coming out from me, right? There are multiple rays of light. All those rays of light will always be parallel to each other. So if you see here, the incident ray is falling parallel from the object onto the surface of the mirror. Now, plane mirror is usually a smooth surface, right? So when the incident ray will fall on the smooth surface, all the ray that is reflected back will also be parallel to each other. Okay. So technically, if they are parallel to each other, will they meet ever? This reflected ray, will they ever meet? No, right? Remember this. This is one major reason why we see our images erect or inverted. Okay, I'll tell you in a little while. So all the reflected ray are parallel to each other. That means in the near future, wherever, even if you take it till infinity, it will never meet, right? Now, let's say it's not a smooth surface. Let's say it's a rough surface. Okay, let's say it's a curved spoon, or it's a slightly distorted mirror. Then what will happen? Incident ray will fall parallel only, because the object is sending parallel beams only. But once it hits the surface, then what will happen? All the reflected ray will go in different directions. And that is why you can get a distorted image or a diffused image, not a very clear image. And that is exactly what happens to when, you go to these museums or these playhouses where, you have illusions, where sometimes you look distorted, your head will look smaller, body will look bigger, or vice versa. This is exactly what is happening. So this is very simple to do. Okay, any doubt?
Ma'am, I didn't understand smooth surfaces. Why?
Surfaces means plane surface, like a plane mirror.
So I didn't understand in smooth surfaces why sometimes why the image is erect.
Images
Erect.
erect. I'll tell you. Just remember that the reflected ray are parallel. I'm just coming to that, right? Okay, so this is what we just discussed. Whenever there's a rough surface, incident ray will always be parallel because it's coming from an object. But once the reflected ray is coming, since the surface is not smooth, it will go in all different directions. But if it's a smooth surface, the reflected ray will also be parallel to each other, right? Now, okay, coming to why. Now, there are two types of images. Just listen to me carefully and then I'll show you the text. There are two types of images. One is a real image. Second is an inverted image. Have you heard about them?
Oh, yes, ma'am.
What is a real image?
Or a real image is the same image, and inverted image, they flip it.
No, what is real image and virtual image? Inverted image. Real and virtual. Okay, what you see in the mirror, is it real or is it virtual?
Virtual.
Virtual. So why are you calling it virtual?
Because it's not real. The object is not real. I can just see it.
Sorry?
Because the object is not real. The object will be with me.
No, but if I'm standing in front of the mirror, I am real, no? So is my image real or is it virtual?
Virtual.
It's virtual. How come?
Because it's just the image.
It's just the image. Okay. And if I see myself, okay, so you go to watch movies, right? Or you've seen a projector. So the image that is being thrown by the projector on the screen, is it real or is it virtual?
Virtual.
That's also virtual. That's a real. Okay, that's not virtual. So what is a virtual and a real image? Real images are images which are formed by actual meeting or actual divergence of the reflected ray. When the reflected ray actually meet, then we call it a real image. When the reflected ray are not meeting and we're assuming that they will meet somewhere, that is a virtual image. Okay, so for example, just going back now, here in this case, we just established that if this is a smooth surface and this is a plane mirror, in the plane mirror, you cannot have reflected ray meeting ever, correct?
Yes.
So that is why we don't see the image somewhere here, no? If this is the object, we see the image somewhere inside, correct? So basically what is happening, we are assuming that somewhere here, these rays are meeting. Okay. And that is why wherever the object is, exactly there you will see the image. In reality, it is not meeting anywhere. But if let's say, usually for lenses, this happens. For mirrors, it will never happen. Mirrors will always give you a virtual image. Let's say this is the convex mirror. Oh, sorry, convex lens, right? So what will happen? Let's say this is the ray. And maybe once they get refracted, they meet here somewhere. So this is the object. And this is the image. So when they're actually meeting, we call it a real image. Now this we will talk about later when we talk about lenses, because in the plane mirrors, there is no real image, right? So that is why there are a few properties of real images. Real images will always be inverted. Virtual images will always be erect. That is why when you see your reflection on the surface of the water, it's a real image, and that is why it looks inverted. Okay, but if you look at yourself in the mirror, then it is a virtual image and hence it is erect. Okay, now another thing, like I said, projector emits a real image. How is it emitting a real image? You know, if you see a projector has this round little reel on it, and you insert the reel and then that reel is projected onto the screen, right? Now, of course, we have digital screens. We don't have those reel system, but it's the same. So how do they project it? Everything should have been looking inverted to us. You know, let's say you've gone to see a movie, everything should have been inverted. But what they do in that reel only, it is initially inverted, so that when it is projected on the screen, it comes out to be straight. Similar thing happens to our eye. Our eye has a convex lens. So whatever image is we getting formed at the end of our eyeball, at the end of our eyeball, we'll do the structure of the eye also. At the end of our eyeball, we have a screen. That screen is getting an inverted image only. But once the screen sends the signal, the nerve carries the signal to the brain. Of course, we can't see inverted things, right? If I'm standing in front of me, I hope you're not seeing me inverted, right? So basically, the brain is giving you a signal that this is how it is supposed to be seen. So the brain inverts it again. So there's a double inversion, and because of that, we see any objects erect, right? But convex lens is present in our eye, so most of the images are inverted. Now, why I say most? Because it depends upon the distance also. That we'll study a little later, right? So now let's just come back to the images that are formed by the plane mirror. So this is the definition. of real image and virtual image. So real image is actual convergence of the light rays. Okay, and it will be always formed on a screen, whereas a virtual image is an apparent conversion. We are just assuming that it is converging. It's not actually converging, and the virtual image can never be obtained on a screen. So since on a projector we are seeing it on the screen, that means it's a real image. Okay, now coming to just going to skip this and go here. Okay, now the images that are formed by a mirror or a plane mirror specifically has a few properties. First, a plane mirror will always give you a virtual image. Okay, that means if it's virtual, the image will always be erect. Okay, secondly, the image is always the same size as the object. It's the same height, same width, same length, everything is same, exactly carbon copy. Third, the distance of the object from the mirror will always be equal to the distance of the image from the mirror. A lot of questions come from this. So for example, they can ask you that if the distance of this person from the mirror is 2 meters, and okay, I'll give you one question. So let's say this person is standing about 2 meters from the mirror. Okay. And there's another person standing behind the person who is about 3 meters away from the mirror. Right? Total. What is the distance of the image from this person?
7 meters.
7? How come?
5 meters.
5 meters. So from here to here, it will be 2 meters only. Right? So 2 plus 3, 5 meters. So questions like this can come, or simple questions that let's say I placed an object at 2 meters. What is the distance of the object from here? So a lot of questions, like not a lot of questions. One question definitely will come from this topic about the distance. Okay. Another thing is, so these are the 3 rules. Fourth one is that the image is laterally inverted. That means your left becomes your right becomes your left. That's the only change that you can see when you see yourself in a plane mirror. So obviously in front of the mirror, if you stand, if I raise my right hand, it will be my left hand and vice versa, correct? So these are the rules given: always erect, same size as the object, laterally inverted, distance of object from mirror is equal to distance of image from mirror, and image is always virtual since it's erect. Okay. Any doubt?
No.
Okay, great. So this is what they mean by lateral inversion. And that is why, if you have noticed, nowadays, of course, most of the people don't write it, but you know, still old ambulances, or if you see carefully on the ambulance, in the front of the ambulance, it's written in the opposite direction. That means it's written laterally inverted, so that if someone is looking at it from their rear view mirror, they can read the ambulance clearly, right? Otherwise, on other parts of the ambulance, it might be written in the straight form, simple. So now questions on this can also come. That means, let's say last year only, not last year, this, I mean 2020, there was a question where this was given, that this is the letter and it's placed in front of the mirror, right? And they had given multiple options as to how will this look in the mirror. Okay, so simply it will be laterally inverted. That means B will become this, L will become this, U remains the same, and again B will become this. So multiple options will be given to you regarding this. You have to select the correct one, right? And another question had come asking that, you know, which are the letters which might not show lateral inversion. So like H, A, I, O, U, these will not show lateral inversions, correct? Okay. So these are simple questions that you can solve. Of course, when we come to the regular class, we can talk about it. Okay. Now, these are the uses of plane mirrors. Of course, there are multiple uses of plane mirrors, but a few are given. So first, of course, plane mirrors are used for at homes. Maximum times we use them for looking at ourselves in the mirror, and at our houses we use them. Second is they are used to provide some kind of false dimension because they are reflecting all the images. So let's say if you want to make a room look bigger, or you want to have multiple images at the same time, like, sometimes in showrooms or even in your trial rooms, when you enter the trial room, there are minimum of 3 mirrors, right? So that you can see yourself from all angles. So it can be used for that. And third, of course, it is used in kaleidoscopes, periscopes, solar cookers, because it will accumulate all the light. It will reflect off the light falling on it, and it gives a slight illusion, right? Okay. This is, I'll just discuss this quickly and then I think we can stop with the demo. All right. Now, sometimes what happens is, for now, for class 7th, only questions on this will come as to if there are more than one mirror, if more than one mirror is placed. Okay. So let's say 2 mirrors are placed. So obviously one mirror will be reflecting the image. So let's say these are the 2 mirrors. So object is placed here. This object can be seen here also. It can be seen here also. Now the image that is being formed here can be an object for this and vice versa. So multiple images can be formed, correct? So how will you determine that? This is exactly what happens in a trial room also, right? You can see yourself inside the mirror, then in the mirror, and so on and so forth. So how will you determine what is the number of images that is formed? So first of all, what you'll do is an angle will be given to you. That means the angle at which these 2 plane mirrors are arranged. That angle, we are assuming it to be theta. Okay. So let's say 2 mirrors are placed like this at an angle of 90 degree. Okay. So first what you'll do is you'll calculate 360 by theta. That means you'll calculate what is 360 by theta is here 90, right? 90. If this is even, what will this be? This will come out to be 4.
4.
So this is even.
Yes.
If this comes out to be even, you will subtract 1 from it. So the total
3.
number of images is 3. If it is placed at 90 degrees. If let's say 360 by theta comes out to be an even number, odd number, then you will do nothing. That is the number of images that will be formed. Okay. Now it can be possible that 360 by theta comes out to be a fraction, right? So let's say this has come out to be 2.6, a decimal number. So of course you can't have 0.6 images, right? Practically not possible. So the number of images that are formed is 2. So you will only take the integer. Even if it comes out to be, let's say 3.9, still the number of images will be 3, because 0.9 image is not possible. Okay. Now, other than that, of course, the placement of the object is also necessary. Is it symmetrical, not symmetrical? In that case, what you will do, that we'll discuss when we come to the regular classes. Okay. Right. Any doubt till here?
No.
Then I'll stop here. Let me just stop sharing. Sir, are you there?
Hello. Yeah, thank you, ma'am, for the session. Did you like the session?
Yes, sir.
Okay, then so we will talk to your parents. Okay. Thanks for today. Thank you, Aishwarya, ma'am, for the session.
Thank you.
Bye,
Bye.
everyone.